So we're on here. So this is a lesson on nth roots and radicands that contain variables. So let's start by considering this, what we call this is a radical expression, but notice it has a 3 tucked in here and with our radical sign. Okay? Now, when it doesn't have a number there, what do we assume? It's a square root. It's a 2. It's a square root. So let's talk about what this means. If we say this means the cube root of x, so I've written that over here, the cube root of x, and that means what number multiplies by itself 3 times to get, that's right, to get x, all right? So when I say this title is nth roots, that just means these numbers are going to change. I could put a 4 in there, I could put a 5. If there's no number again, that's default is that it's 2. So let's start with the cube root of 8. What number multiplies by itself? Go ahead, Ethan.
8 or 2.
2. Does everybody understand why the cube root of 8 is equal to 2? It's because 2 times itself 3 times. 2 times 2 times 2, or 2 cubed, equals 8. So that makes it the cube root of 8. Okay? Now, another one. Cube root of 27. What do you think, Caroline? What would multiply by itself 3 times to get 27? Let's go lower.
3.
It's 3. Okay. So you understand why? Because 3 times 3 is 9, and 9 times 3 is 27. So, okay? So that's the cube root of 27. Now let's get our calculators off, and so what I want you to do is, I need to teach you how to do this. So these first 2 examples are perfect cubes, right? Because they have rational cube roots. But now we can still find there is a number, it just happens to be rational. What number, we're going to do an estimate, what multiplies by itself to get 25. So the way we're going to do that, and I know that people who are listening to the recording can't see what I'm doing here, but I'm on the calculator, and what I want you to, I need to type in the root index first. Actually I don't with cube roots, but I do with the other ones. So what I want you to do is hit math, and that's the button right below the green button. And then I want you to go down, and then I want you to hit 4, and you can see how to access the cube root. And now let's hit 25 and hit enter, and we'll round this to the 3rd decimal place. So 2.924 would be an estimate. 2.924 would be an estimate for the cube root of 2.924, right? Would be our estimate for the cube root of 25. All right, let's see anything else on this page. Okay, that's it for that page. All right, now, next we're going to do the cube root of 64. And your first initial reaction may be that this is imaginary, right? However, remember, when you multiply 3 negative numbers, right?
Yeah.
You actually get a negative, right? So this is okay. So this is not going, this is rational. Not only is it rational, it's real. So what multiplies by itself 3 times to get negative 64? I see people typing your calculator. Let's think through, I want you to think through the ones that we can get, because we got to be able to do these in our head for the most part. It's the ones that have irrational cube roots and 4th roots, etc., that we use our calculators. But this is what I want you to do in your head. So does everybody realize this is negative 4? And so just write that in. Okay? Now, how about now when you see a negative in front of the cube root, we'll just bring that into the end. We'll bring that in at the end. So let's just ignore it for a second. What multiplies by itself 3 times to get 1,000?
10.
10. And then this will make it negative, right? It's not saying that the cube root of 1,000 is negative 5. It's saying that the opposite of the cube root of 1,000 is negative 5, right?
Wait, I thought it was 10.
I'm sorry, somebody said 5 and I just wrote 5 now. It's 10. Sorry, I'm looking at, Reed had a very puzzled look on his face and he's like, how, Reed's not getting this. Why is that? Okay, he does get it. The answer's 10, except negative, right? The negative comes in the end. Okay.
Wait, so it's a negative?
So this just really means, you want to deal with this first, Caroline. So you want to say, what's the cube root of 1,000? And then after you get that, say, okay, now we're going to make it negative, okay? So the cube root of 1,000, which means what multiplies by itself 3 times to get 1,000. And that's 10, right? 10 times 10 times 10. That's what 10. That's 10 by itself 3 times. That equals 1,000. So therefore, that makes 10 the cube root of 1,000. But then we have this negative on the outside, and we'll just multiply that. Or you can, you can either think of that as a subtraction of the cube root of 1,000, or you can think of it as negative 1 times, right? Okay, back to our calculators. What's an estimate for the cube root of negative 65?
4, negative 4.
What'd you get when you did it?
Negative 4.021.
021, okay? Right? Now, let's again, this next one, let's not resort to our calculator on this one, because I want you to realize that 64 is a perfect cube, and so is 27. So what fraction multiplies by itself 3 times to get negative 64, 27, Caleb?
Negative 4 over 3.
Negative 4 over 3. That's correct. Now, how did he know that? Well, he knew that a negative, I can have 3 negatives multiplied by themselves 3 times and still have a negative. What multiplies by itself 3 times to get 64? Caleb realized that was 4. What multiplies by itself 3 times to get 27? 3. Right? Okay, everybody good so far? All right, now, so let's talk about, we'll leave this 10, but really when we talk about the nth root, we're talking about this number. So I don't mean, this is the 4th root of n, but when I'm using that nth roots, I'm actually referring to this number, and that's the root index. Now, so the 4th root of n, so that's saying what? What multiplies by itself 4 times to get n? So, shoot, I already have an answer here, but you can see, what is the 4th root of 81? What multiplies by itself?
3.
Is 3, right? And because 3 to the 4th power will equal 81. Okay? Now, how do we do 4th roots on our calculator? That's a little more involved. So let's go to our calculator. Let's clear it. Now, with this, we've got to type in the root index first. So if I'm doing the 4th root of 78, okay? I need to type in the 4 first. I'm going to type my root index in first. Then I want you to hit math. I want you to go down and hit 5. Okay? Now I know it doesn't look like it, but that 4 is really that X.
Mine was
Okay.
on
Oh, okay, it actually puts it in. So that's an improvement on the calculator, okay? This software is a little dated. And then type in 78 and hit enter, and we'll call that 2.972. 2.972. That's our approximation. Now, if I was to take 2.972 to the 4th power, would I get 78?
Yeah.
It's something just below it, right? Okay, it'd be 77.9 something, okay? Because it's not a perfect 4th, it doesn't have a perfect 4th, I mean, it doesn't have a rational fourth root.
78.01. There you go.
Yep. Okay. Now, oh, that's interesting, it went above it, that means this was rounded, right? If you do that. Okay, so radical expressions with variables. So let's simplify. What multiplies by itself to get x squared, y squared? So now we're doing radical expressions with variables. So what multiplies by itself to get x squared, y squared? xy, right? Because if I multiply, Caroline realized if I multiply xy times xy, right? Well, I add the exponents. What are the exponents on my x's here? 1. So that makes x squared. And what are my exponents on my y? 1. So that makes that x squared. So that's the square root of x squared. What is the fourth root of 81t to the 12th? All right, so think about it first. Everybody think about it. What multiplies by itself? So you can't treat those separately. So what multiplies by itself 4 times to get 81?
3.
Okay, 3. And what multiplies by itself 4 times to get t to the 12th?
T to the third.
T to the third. Now that's for you to realize in the other class, this is not a coincidence. What's 12 divided by 4?
3. Does that happen every time?
It does. Yeah, and the reason it happens is because
Why is it different for,
it's not really. If I'm doing square roots, right, if I have x squared, what am I doing? If I take the square root of x squared, right, what's that?
X.
X 2 divided by 2, 1, right?
I thought this on the web for what are you working on?
That's what you drew.
Yeah.
Not me.
That is only you.
It came from up there.
Yeah, it's right. Okay.
Okay, all right, we're not gonna worry about it, nobody did it on purpose. Okay. Oh. All right, now, so are we okay with this? How do we know this is right? We do a little check, you don't have to do checks, but what's 3t cubed to the 4th power?
81t.
81t to the 12th, yes.
Does the division, like 12 divided by 6, does that only apply to the exponent?
Very good question, and that's right. It's not 81 divided by 4, right? It's the exponent, yes, important clarification she just said.
You're welcome.
Okay? All right? All right, now, okay, here we go. Simplify. The opposite of the square root of 25 x to the 4th y to the 12th. The opposite of okay, so let's ignore the negative. Let's go ahead and just bring it down to the final answer there, right? What's the square root of 25? What's the square root of x to the 4th?
X squared.
What's the square root, this is the tricky part. What's the square root of y to the 12th? Y to the 6, right? So it's 12 divided by 2, right? Very good. Okay? All right, last problem. We got 2 word problems to look at. But 5th root of 32, x to the 5th, x to the 15th, y to the 5th. It's the 5th root of 32.
2.
We agree? So that finishes the recording, I'll come out, right? So that finishes, we're recording this.
Oh, I have the answer.
So 32, so that 5th root of 32 is 2. 5th root of
3.
x cubed. 5th root of y to the 5th?
Y.
Okay? Does everybody know why?
Hey, good one.
All right. I forgot to, photocopy these 2 word problems for you, but they're both in the textbook, so this is problem. So make a note that these notes are from C textbook problem number 105, and they're not assigned problems. So that's how you can reference your notes without having the the turnout. So if a cubical box has a volume of 2 cubic feet, it's not saying that the side lengths are 2 feet, it's saying that the volume is 2 cubic feet. How long is each side? Who remembers from last year how you get the volume of a cube? Okay, so side cube, right? So volume equals side cube, right? So what this is saying is we're going to call our side x. The volume is 2, right? Or 2 cubic feet. And that equals x cubed, right? Because I'm making x our side length here. So what is each side length here? So let's get our calculators. Everybody understand if this is going to mean that each side length is actually going to be the cube root of 2. Right? Because 2 is not, again, 2 is not the side length here, 2 is the volume. Not divided by 3, take a cube root of 3. Remember, divided by 3 is different than taking a cube root. Divided by 3 is the same, is different than taking a cube root of something. We're taking a cube root of 2. So what,
1.60.
okay, okay, so let me back
I
this
have
up.
1.25.
This problem's a little awkward because of this 2. 2 doesn't have a perfect cube root, right? So what if it did? So let's think of a problem that has a perfect cube root. Let's say the volume was 27, right? What would be if the volume was 27 cubic feet? So cubic foot, what does a cubic foot look like?
Like the ones.
It's like a box that would hold a basketball. It's like a box that would hold a basketball, right? So what if it had what if we had 27 cubic feet? It's a pretty big box, right? What would each side length equal for a 3, right? But this it's not a perfect cube, right? It's still a cube, it just has irrational side lengths, right? So what did it equal?
20.260.
26, we'll leave it at that, feet, right? Remember, the 2 was cubic feet. Let's go to this next one. So the power generated by a windmill related to the speed of the wind, the power generated by a certain windmill is related to the speed of the wind by the formula S equals the cube root of P over 0.02, where S is the speed of the wind, right? And P is the power in watts. Find the speed of the wind when the windmill is producing 400 watts of power. So we're giving us P here. So S equals the cube root of P, which they give me is 400 over 0.02. So we're going to put that on our calculator. So we're going to type in, we're going to hit math and 4 again, and then we're going to go 400 divided by 0.02, and close your parentheses there. All right, and if your calculator doesn't automatically put parentheses, make sure you put those in, because we need to take the cube root of that quotient.
Wait, parentheses over 400 divided by 0.2.
Right. And that's going to get me, so that tells me that that my final answer, 20, we'll call that 27.3. Well, remember it's cube root, so that's going to tell me that the speed of the wind is approximately equal to, what was it? 1.4 miles per hour. Okay? All right, we're going to stop the lesson there.
Bye.
And,
Bye.
all right.